Hello students, welcome to SmartKidz tutorials. In this video, we will be completing the chapter of Is Matter Around Us Pure? This is the third video of this chapter. So you can watch the first two videos to understand how we got to this part over here and to learn about separation of mixtures where we in the previous video we learned about separation of mixtures where there are solids and solids as part of the mixtures. We also learned about how to separate mixtures involving the liquids or solids in liquids. Okay, now we in this video we'll be learning about separation of mixtures involving liquids and liquids. So let's begin. For separation of mixtures of two or more liquids, okay, whenever we have two or more liquids and we need to separate them out, we can use a process of fractional distillation, or we can use a separating funnel in order to separate those two liquids. The first process of fractional distillation. So what is fractional distillation? Okay, we have learned about just simple distillation. This is fractional distillation, a mixture of miscible liquids. Miscible liquids means liquids which dissolve or mix with each other very well, not like two insoluble liquids where they are forming separate layers. These are mixtures where there are two liquids which mix very well with each other, can be separated by the process of fractional distillation. And it is a process in separating two or more miscible liquids by distillation, the distillate being collected in fractions. Again, we know about distillation, and distillation works on the basis of boiling point. So here also, if we need to separate out a mixture involving two miscible liquids, then we need to first find out what are their boiling points, and based on their boiling points we can separate or purify the mixture into individual components based on their different temperatures. At temperatures, I mean at which these two miscible liquids boil. So the separation of two or more liquids by fractional distillation depends on the differences in the boiling point, just as I have discussed right now. Where do we use fractional distillation? Actually, it's used in a number of industrial processes. Very important to separate two miscible liquids. Here the example that is given is liquids like acetone and water mixture can be separated by using fractional distillation. It is used to separate gases of air. We know that air consists of a number of gases, and if we need to separate out these gases, then we need to do so by exploiting their boiling temperatures, or the temperatures at which these gases boil. Then the most important commercial use of this fractional distillation is to get various products from crude oil. Okay, we use petrol, diesel, then we use aviation fuel, means fuel that is used by the aircrafts, airplanes. Apart from that, we use kerosene for domestic cooking purpose. At least we used to use sometime back. Some places of India do still use kerosene. Apart from kerosene, there are other like LPG, or liquefied petroleum gas, which we use our cylinders for cooking. And there are many more like naphtha, and also like bitumen, something that we asphalt to tar our roads. All these are available, or we get them from one single substance, that is one single mixture, that is your crude oil. And crude oil, we have specialized regions from where this crude oil is extracted. The Gulf region or the Middle East is rich in this crude oil. Okay, and most of our supply, at least most of the supply in India, we get it from the Gulf region. And this crude oil has taken millions and millions of years to form, and there are special ways in which how we extract this crude oil. And once this crude oil is extracted, then it is sent downstream to other companies who do the separation using this fractional distillation process. They separate them out, then they process it further in order to refine the product, to purify the product, and then sell it to the consumers, that is us. Okay, they may either brand it or they may sell it at public gas stations and so forth. All this takes a huge cost. There's a huge cost involved, and that is why the fuel that we use today is expensive and keeps rising, because these are in limited resources, and these are non-renewable sources. However, about non-renewable resources, we learned that in sources of energy, here we focus only on fractional distillation. And so fractional distillation, we exploit the various boiling temperatures of these constituents or these components of this crude oil in order to separate the crude oil out into various components, which has wide applications in today's world, which we can use in different places for different purposes, mostly for transportation. So here we can see a picture that is seen in front of us, and that is actually a fractional distillation process that is shown over here. Out here is your crude oil. Okay, the crude oil is stored, and then we have a steam boiler which supplies the heat, and at various temperatures, right from bottom to top. Okay, you have different temperatures, and these temperatures are fine-tuned or adjusted to match with the boiling temperatures of the various products that we need to be separated out. And as you see, these pipes coming out from this fractional distillation unit, okay, these are having different, or this actually contain various different products. Okay, and further it undergoes treating and so forth, which is called this is also called as a cracking unit, leads to separation of this various products. You see over here the products: the propane, butane, used for your gas lighters, small cylinders and so forth. Petrol, we know what is petrol. Kerosene, some of us may have not come across kerosene, but if you ask your parents and so forth, they would know about kerosene. You would be, once upon a time you were getting it at your ration shop as well. Used for your gas stove to cook or to boil water. Jet fuel, used for, as I said, aviation fuel, used for aircrafts. That's how you can fly from one area to another, because that fuel is different from the fuel that you use in your two-wheelers or four-wheelers. Then of course you have diesel fuel used for transportation vehicles like your trucks, lorries and so forth. Then your heavy fuel oil, which is used in heavy industries. Apart from that, you have your naphtha. So anyways, so the fractional distillation process is highly exploited in the petroleum industry. This is called as the petroleum or petrochemical industry, because the output that we get are known as petrochemical outputs. See the boiling point out here, that is the highest, 500 greater than 500 degrees Celsius, and right on the top the boiling point which is less than 0 degrees Celsius. So you see how much the temperature varies, and here it is supplying the heat, because you need heat to boil this product, and the steam boiler does this work out here. And there is a continuous supply of crude oil which is supplied. There are various storage tanks close to this distillation units. Okay, this, and if you notice over here, then you see there is a flask. This is known as the distilling flask, which contains the liquid or the mixture that we need to separate out into various components, and it is in close proximity or direct contact with the burner. So when it begins to boil, the vapors rise, and you have this fractionating column out here. This fractionating column is made up of beads which increase the surface area, allowing cooling to take place faster. The cool vapors rise up, and here you can have a temperature is in a thermometer is inserted out here, which allows for measurement or finding out what is the temperature of the vapor. And then you have this distillation or this distillation unit or this fractionating column attached to a condenser which promotes condensation or promotes conversion of vapors into liquid. This is consisting of cold water which is supplied externally, which further allows cooling of these hot vapors. And these vapors then cool down, and as they cool down, the gas turns into water or liquid. Considering you may not always have water, you may have some other liquids. The liquid then the vapors condense to form liquid, and we collect it drop by drop in this receiving flask out here. The drops that are collected in this conical flask, it is known as a distillate. And you must know over here the temperature is highest over here right at the bottom, which is in close contact with the burner, and the temperature keeps reducing as we move away from the Bunsen burner or from the flame. Okay, so we have an activity, and the activity is about separation of two miscible liquids, that is alcohol and water. Alcohol and water mix with each other very well, but if you need to separate these two miscible liquids, then we need to exploit or use the fact that they have different boiling temperatures, or they have alcohol boils at 78 degrees Celsius, whereas water boils at 100 degrees Celsius. So this difference in this boiling temperatures can be very well used or exploited or taken advantage of to separate out alcohol, a mixture containing alcohol and water. And so once again, the distillation unit similar to the one that we just saw. Okay, and this is how we collect the alcohol. The alcohol will come out first because 78 degrees you will reach first, right? And then you will come to 100 degrees Celsius. So alcohol having a boiling temperature of just 78 degrees Celsius will boil first, the vapors will rise first, and obviously it will we will be able to collect the alcohol in this distillate flask first. So alcohol will be the first distillate, followed by water, which will boil only at 100 degrees Celsius. Okay. Next activity is a separation of mixture of gases from air. So we saw about separation of a mixture of liquids. What about separation of mixture of gases of air? Okay, now in this we have air consists of various gases like nitrogen, argon, oxygen, carbon dioxide, etc. And then if we need to separate them out from another, we can do it by the process of fractional distillation. But for this process we need liquid air. That means air needs to be liquefied, and that is only possible at very high pressure. So we need pressure to liquefy because it's a gas, and only under pressure the gas liquefies. That is why the liquefied petroleum gas that we get, the LPG, the cylinders that we get for cooking, okay, those are stored in high pressure metal, I mean cylinders, and only because they are pumped at high pressure and stored at that particular under that pressure in those cylinders, that is why the gas that we get, it is in liquid form. The moment we turn the nozzle on, the gas looks to escape. That means it looks to change from it looks to vaporize. It looks to change from your liquid to gas, and then we light the gas and we get a flame that we use for cooking purpose. So you see, that is why those cylinders are tough. They are hard metal and they are heavy, because they need to store that gas in liquefied form under high pressure. Why do we need to transport it in cylinders? Because it is convenient that way. Okay, gas looks to expand, and if you need to utilize that gas, then we first need to trap that gas in a place, and when we trap that gas in a place so that we can transport it easily, it gets liquefied under that pressure. And that is why we have, whenever you shake your cylinder, you will be able to hear sound of a liquid which is in the cylinder. So liquefied, how do we once we have liquefied this air, which consists of various components, which will be nitrogen, argon or oxygen, they all have separate boiling points, and their boiling points are not the same as that of water. Water will be 100 degrees Celsius, whereas in case of nitrogen it is minus 196 degrees, argon it is minus 186 degrees, and the boiling point of oxygen is minus 183 degrees Celsius. So the air that we need to liquefy, first we need to remove any dust or impurity that may be there from that, any water vapor and carbon dioxide, because we don't need all of these. Once that filtration process has taken place, then the air needs to be compressed by increasing the pressure. And once compression takes place, the pressure increases, air is available in liquefied form. Then it is cooled by decreasing the temperature to get liquid air. Then the liquid air is slowly allowed to warm up slowly in a fractional distillation column, and these gases then they get separated at different heights depending upon their boiling point. And liquid nitrogen has the lowest boiling point, so it is collected first, and liquid oxygen has the highest boiling point, so it is collected last in the beaker. And here you have schematic picture diagram that you can see how air first is taken in, then it is heated up and it is squeezed basically to increase the pressure, okay, the area in which that it is present. Once it is compressed, the pressure builds up, then it is compressed air is cooled slightly, okay, and is allowed to expand further and turn into liquid, and then this liquid goes to the cylinder, and at various temperatures you get it is allowed to warm up to boil at various temperatures. And you see nitrogen gas is collected first because it is at minus 190 degrees Celsius, and liquid oxygen collected last. Okay, separation of two liquids is also possible by using a separating funnel. This is a very simple experiment and is widely used in labs to separate out immiscible liquids, not miscible. That means they don't mix with each other. If you mix them and you allow them to stand over a period of time, they will separate out into separate layers. You see over here, there's an aqueous layer, organic layer down, and here the organic layer is on top, aqueous layer down. And once they separate out this way, then all we need to do is, once the layers that are formed are quite stable, that means no more separation is taking place between the two, then we need to turn this nozzle on and collect this part, leaving behind the aqueous part. So we collect the organic part first and leave behind the aqueous part. And in this case, we'll collect the aqueous part first and leave behind the organic. It depends on their densities, how light one is compared to the other. Applications: to separate a mixture of oil and water. We know oil and water don't mix well with each other. It is also used in the extraction of iron from ore. The lightest slag is removed from the top by this method to leave the molten iron at the bottom in the furnace. Coming to the physical and chemical change that we experience, uh, some of the physical and chemical changes that we experience. In case of physical changes, it brings about change in physical properties such as physical state, shape, and size. Okay, for example, you have a block of ice, right? And ice, when it is kept out at room temperature, it will melt. That means it will change its physical state from a solid to a liquid. And if we leave it still lying further for hours together, it will evaporate. That means it will get converted from liquid to vapor, that is gas. But water still remains water as far as its chemical composition is concerned, a chemical formula is concerned. H2O remains H2O. Only the physical state changes from solid to liquid to gas. Okay? Whereas in case of a chemical change, it brings about changes in the chemical properties because there are various combinations that take place that leads to a very different entity, a very different substance or very different compound. Okay, whereas here water, which is a compound, does not change. It will remain as water. Only the physical changes. Whereas in case of chemical change, a new compound is formed which will have new properties. Okay, so the physical change, it is reversible, but the chemical change that we get, okay, it means that they are permanent. I told you in physical change there is no new substance formed, just the state is changed. The color may change, or the shape may change, or the size may change, or the form may change. But in chemical change, a new substance is formed. And some of the changes, physical changes that we are talking about, involve color, hardness, rigidity, that means how hard or tough it is, fluidity, density, melting point, boiling point, etc. Okay. Whereas in case of chemical properties, we refer to the odor, that means the smell, inflammability, meaning how soon it can catch fire, and there are many more chemical properties that uh, we can see has changed in the new substance that is formed. Coming to pure substance, we spoke at the beginning about matter consisting of pure substances as well as of mixtures. So we have completed mixtures, and now we focus on pure substances. So pure substances is divided into two types on the basis of the chemical composition: elements and compounds. Okay. Now elements meaning it will comprise of single type of molecule. I'll have a look over here. You have gold, okay, that is an element, but water is a compound because water consists of hydrogen and oxygen coming together, only then water. And diamond comprises only of carbon. Okay, so when it is comprised of just one type of what do you say, atoms, then they are known as elements. But when you have two different elements coming together, then they form compounds. So elements, according to Antoine Laurent Lavoisier, a French scientist, element is a basic form of matter that cannot be broken down into simpler substances by chemical reactions. It is divided into three types, which are metals, non-metals, and metalloids. So there are three types. Metals elements are divided into three types, that is metals, non-metals, and metalloids. So we look at properties of metals. Now metals have a number of properties, okay, and we know we have come across metals. Some of the metals that you see in front are copper, silver, iron, gold. Now these are lustrous. Lustrous means they have a shine. Okay, you'll see a shine on gold. So you'll see a shine on any of the metals. They have a shine. They are not dull. Then metals make sound. You see your bell in the school, you may have noticed, they are able to make a sound. They are known as, that is known as, the property of making sound is known as sonorous. Metals are malleable. That means they can be beaten into sheets. They don't break when we try to hammer them into sheets. Next, metals are also ductile. That means we can draw them into long wires. That explains why we use these metals for our wiring system and so forth. Okay. Coming to wiring, metals are excellent conductors of heat and electricity, and that is why metals are always used for cooking vessels and for our electrical circuits to provide electricity to our houses, to our offices, schools, and establishments. Various examples of metals are there. There are many metals that you can come across. Some of them are listed here: iron, gold, silver, copper. There are others like sodium, potassium, and so forth. Non-metals, on the other hand, have exactly opposite properties of metal. That means they are not good conductors of electricity. They do not they are not good conductors of electricity. They are not good conductors of heat. Then they're mostly, like, some of them are gases, and they do not make a sound. That means they are non-sonorous. They can be beaten into sheets. That means they are not malleable. They are not ductile, non-ductile. That means they can't be drawn into wires. So almost opposite of that. Remember, but we also say that metals are hard, but there is one metal which is not at all hard but actually liquid. That is mercury, that you find in your thermometers. This is a point to be noted. So some non-metals examples would be your gases like hydrogen, oxygen, fluorine, chlorine, and so forth. Metalloids are those which have properties between metals and non. They exhibit properties, little bit of metal, little bit of non-metal, and they do have applications. Examples include boron, silicon, germanium, mostly used in semiconductor industries, in automobile or your cell phones and so forth. They have wide applications. Some are listed here: boron, silicon, germanium. Silicon is also used in a solar industry. Arsenic, antimony, tellurium. So some examples listed over here. Compounds. Elements, when they come together, they form compounds, I told you. And exactly over here, see, hydrogen is an element and oxygen is an element. But when two atoms of hydrogen combine with an atom of oxygen, we get a compound known as water. Similarly, another example is given here: chlorine. When it joins hydrogen, that means one atom of hydrogen, which is an element, joins with one atom of chlorine, it forms something called as hydrochloric acid, which is HCl. So this is a compound. Okay, compounds are formed from elements, by two or more elements coming together. That is what is a compound. But they are always in some fixed proportion which never changes at all. So water will always be found as H2O. Carbon dioxide will always be found as CO2. And HCl will always be found as HCl and nothing more than that. That means it can't be like H2Cl, or two atoms of hydrogen with one atom of chlorine. No. HCl will always be HCl. That means it will always have one atom of hydrogen and one atom of chlorine. And similarly, water will have two atoms of hydrogen, one atom of oxygen. And carbon dioxide will have one atom of carbon linked with two atoms of oxygen. What are the differences between compound and mixture? Now, compound and mixture are two different things. Let's not get confused between the two. Mixtures consist of two or more substances. Okay, when we speak about that, we speak about, like, for example, salt in water. Now, salt is a compound, and that is NaCl, sodium with chlorine. The two together form a compound. This is one compound. And you have water, which is H2O. Now, salt mixed with water. So that salt makes up one substance, water makes up another substance. And these two, when mixed together, make up a mixture. Whereas when we speak about only water, water is made up of two elements coming together, hydrogen and oxygen, in a fixed proportion. These, when the elements come together, they form a compound. When the compounds come together, they form a mixture. As simple as that. Okay, and the compounds, the proportion can vary, the amount can vary. Water, you can have 2 ml of water or 2 liters of water. Water will always remain water, but in case of the chemical composition of water, water is only formed when 2 atoms of hydrogen combined with 1 atom of oxygen. Okay, you can't have 2 atoms of hydrogen joining with 2 atoms of oxygen. If that happens, we have a brand new compound that is called hydrogen peroxide, just for your knowledge. But the thing is, by changing the proportion or the amount in which oxygen joins with hydrogen, you are changing the compound. It will become a new compound. So the proportion of a compound in which the two are present never changes. You can have large amounts of mixtures, okay, but the components of the mixture will remain the same. They will not change at all. Okay, so remember, elements come together to form compounds, and compounds come together to form mixture. That is just so. With this, we complete the chapter on is matter around us pure. Now we know that matter is not just made up of pure substances, but also has got mixtures. I hope you found not just this video but the other 2 videos also in this series very helpful, and if you have found it so, please share it with your friends and classmates. Subscribe to the channel and like this video. Keep watching for more such videos. Thank you for watching.